Okay, it's a bit weird. One system says I am live streaming, and the other system says I'm still offline. And right now I'm not sure if I'm actually speaking to someone or if it's still offline, and I don't get why it's happening. Oh, this says I'm streaming and uploading data live right now, and it's apparently received. But this says there is no endpoint that's receiving any data. You know what, maybe I'm just gonna ignore that. Right. Let's just check the browser. Okay, apparently my stream is live for 2 minutes now, almost. So I guess it's working, and I'm just... I'll have to look into this later. Let's just pretend we just started freshly. Technology. Of course, today it has to break. Today of all days. For old time's sake, let's write a simple little program. Classic one. And of course, we learn from our past mistakes. Include the read key, so we can actually pause and wait for things to happen. Let's try it out. It's probably not going to show, is it? The way today is going? Yeah. Okay, let's just fix that up quickly. There, we should see the output. Wonderful. Works, but maybe let's change this up. Let's not do world, let's do Twitch. It sounds more appropriate for now. That's technically not quite right. Well, luckily we have an undo button. Maybe we can just go back. Let's just go back to world. That's good. That's good. Although maybe not world, maybe just... Nah, that doesn't sound right. Maybe let's just go back to Twitch. Twitch was good. So let's just go backwards and then do the forward button to go back to folks, not Twitch. Guess I have to do this manually. Or maybe let's try... No, that was fine actually. That was fine. Let's just keep at it. But maybe, yeah, let's go back to world. I closed the window, so now the undo button is not working at all. I'm a mess today. I'm a mess today. Well, good thing I didn't work on a large project that involved more than a single word change. Imagine I wrote an entire class just to rewrite it, and then rewrite it again, and then accidentally close everything, so now I can't even undo it, and I have to write it a 4th time. That'd be a pain. That would take a lot of unnecessary time. But it's not like that never happens, right? You work on a large project and you just try to figure out a certain bug, and you maybe write some prototype code and you rewrite some parts to see how everything behaves, and in the end you might figure out the bug, but you just completely destroyed your program. You made all these little changes everywhere and now you have to undo them all. And if you're like me and you maybe want to clean up in between, you close the tab and the undo doesn't work anymore. Or maybe if you've done that over the course of several days, and so the data was not available to just return your code to the old state. That'd be a problem. That'd be a problem, especially if that program is supposed to make money. and now your boss is sitting behind you asking why you don't release the new version. It's urgent. The customers are crying already. And now your boss is crying, and now you are crying. And you have to just go through your entire code base, check everything, rewrite everything, because you do not know where you made all these little changes that apparently screw the entire workflow of your program. Unless, of course, you have a backup. If you were smart about it, you would have made a backup of the entire project before you made all your little changes. That'd be the smart way to do it. You make a backup, and you then make all your changes to figure out the bug, and once you find it, you just delete everything you have and load the backup. Go back to the state as it was before. Just like the undo. Only not limited to the active tab inside the running program, and instead based on some files you have stored away securely to go back to anytime you want. Seems much better way to handle it. Of course, if you're already starting to make backups, it might also be a good idea to make all these backups in regular intervals. Whenever you make big changes to your program, maybe just make a backup of your code as is, and then make more changes. And whenever anything goes wrong, you can just go back to the last backup. And if something really goes wrong, you can always load an older backup and compare that. See if that maybe had a certain issue or didn't have a certain issue, and then either work from there, use the old backup and rewrite all the changes since then, but without the bug, or maybe just to help you figure out or narrow down where something went wrong. So you would have to make backups in regular intervals and keep those files stored away somewhere. And you have to organize everything, of course. Like probably put some dates next to it so you know when the backup was made. Maybe add some descriptive text in the file name. Maybe you make a separate file to store the information for what backup has what content. Or maybe include that in the backups themselves somehow. It's a text file, readme or whatever. That's a lot of work though. At least if you do it manually. So why not automate that? Why not write a program that does the entire backup for you and stores it away securely in some way? Maybe just make a zip file and also include some text file that contains a description of what the backup is and when it was made. And all you have to do is press a button, then maybe write in some text to tell you this backup contains this and that. And then later, if you need to load an old backup, you just tell the system, please load the backup from then or there with this or that description. And does so. That would be very convenient and very useful. So of course it has been invented a long time ago, and then invented again, and invented again, and again, and again, and again, and we call it source control. And this program is reinvented so often that we now have lots of choices in terms of source control. Different systems that have different philosophies and work different ways, but they all have in common that they're basically like the undo function in my program, and that they record sort of what I do in my project and allow me to make little checkpoints at certain intervals to keep track of my changes over time and to allow me to go back to the state as it was a month ago, a year ago, a decade ago maybe. Depends on how long you've been working on that project. Maybe decades plural. They are very old source control systems. And they're all very old projects stored in those source control systems as well. The one we are focusing on today is one of the more known ones. It is called Git. And you can see it in the top bar here. I have in Visual Studio in the current versions a special menu called Git because it has been integrated into Visual Studio. And that means you can use the most common functions of Git, the most common ways to interact with it and use it from within the UI in Visual Studio, which is convenient. But Git itself is a command line program, and there will be times when you do have to rely on the command line because specific tools and interactions are things you can do with Git, because Git is very powerful and very, very extensive. They're not presented through the UI in Visual Studio. You might be able to get a UI if you use a dedicated program for Git or source control. There are special programs that are purely there to organize your Git, for you to interact with your Git repositories. And they have a lot of more control over the Git and are more specialized in making it easier for you to interact with things, but even those will have their limits. In the end, the purest way to interact with Git is through the command line. So while you don't need it, you should try to get familiar with it, at least a bit. Like the fundamentals to get an idea of how you interact with it in the first place, so that when you do get into this situation where you have a very specific problem, you know how to apply the solutions you find online. Happened to me a couple of times, had some very obscure things happen to me, had to go through Stack Overflow and find some very interesting commands that I then read up in the documentation on Git, that I then experiment with in a demo repository before I do it in my productive environment, because that can actually mess up my entire system. But what we're going to do today is just use the UI as it is in Visual Studio, because we're only talking about the basics, which are what you're going to use 99% of the time. Probably. Well, 99 is maybe too high. Let's say 90. I guess there are teams that use some more special things that I'm not used to, that our team doesn't use, so let's say 90%. Now, to use Git, we first have to create a repository. Repository is basically the overarching structure that contains all your little backups, so to speak. What I mentioned earlier, I make a copy or make a backup of my source code with some additional information like the date and some comments, and I have to store them somewhere. And the repository is the place where you store all your backups collectively. And if you're actually actively working on it, then your repository will also include your source code. Or maybe it's the other way around. You can see it also like your source code, your entire project, the solution as it is, will contain one subfolder containing the entire Git repository. If I go to the directory, no, that's not gonna work. Wait, let me check something here. It's not... Ah, okay, no, that's fine. So I should be able to just make a screenshot like this. You can see my solution right now. All the different projects and the solution file. Something interesting is at the top. You can see, let's maybe use a different color. Let's use a different tool. What do we have here? Let's use some red. Ooh, that's a thick line. There. Nah, whatever. the .vs folder. You can see it's slightly brighter than the other directories because this is a hidden folder. So unless you specifically tell the File Explorer to show you hidden files, you wouldn't see it. Also very common, it starts with a dot. It's very common in Unix system as well, where the hidden folders are dot folders, dot directories. Hidden folder, it starts with a dot in the name. This is some infrastructure you're not supposed to interact with directly, because if you do, you can actually break systems. Now, I can use this button down here, for example, or I can use this button in here, or I can go to the Git menu and go to here, and it will allow me to create a Git repository. Here are all the different options I have, and I'm gonna ignore all of these, and I'm gonna use local only. Like that. And I'm just gonna keep all the default values in here because they're fine for me. And I just click on create, and that's it. I now have a Git repository. You saw some things pop up briefly and then disappear. We're gonna talk about all of this in a moment. Let's have a look in the directory structure first. Look up here. Actually, no, let's look the whole thing. There we go. If we look up here, we now have a second hidden folder called Git, or well, .git. That is your entire repository. All your backups, all the data you stored and secured, and all the metadata is all stored in this one subdirectory. If you delete this directory, your entire repository is gone. Only your active files will still remain, everything you have open, but everything that you stored before will be gone. So be careful with that. It's very useful if you need to clean up some test projects, like if you're just experimenting with Git, for example, or experimenting with creating the Git repository, then it's a very easy way to just reset everything. You delete the directory. Don't do that in productive environment or in actual big projects. You lose everything. Well, if you don't have any secure backups somewhere else. We'll talk about that later. You also notice down here are two more files that will get somewhat important later. We'll just ignore them for now. Up here, that's the big one. Don't touch. Don't change. Ignore it. It's important, keep it there. Now that we have a Git repository, what can we actually do? Well, let's say I want this output in a separate method. Let's say I make a private static void greet, and then I'm just gonna move that out here, and then call that method like so. Code still works, just as before. Well, of course it is. And maybe I want to save the current state. Maybe I want to make sure that what I did is secured. Well, first let's have a look at the area down here. This tab is Git changes. You can also open that through your menus, and you cannot see the menu, I just noticed. So, just for comparison, this is what my menu looks like. Those are all kinds of different options that are available through this menu as well. You can also find that in View. You go to View, you also have your Git changes. That's the tab I have in the bottom right. The little window here, the Git changes. Let's make that go away. Oh, also important, if that's not already on, if you go to your options in Visual Studio, you go to source control and you select Git for the plugin. Should be the default, but if not, you can change it there. And now what we see here in the git changes is every change we made since the last time we made a backup. And that happened when we created the repository. When I used the menu from Visual Studio, it created a repository, and Visual Studio itself did some extra steps besides just creating the repository. It also essentially told Git to save the state the solution is in. So everything that was my project and the entire solution at the moment I made the repository is now securely stored in our Git repository. And the only change I made since then was to move out our greeting message to a separate method. So you can see we have one change in this file program.cs in multidimensional undo in our solution, which is this file. You also see two colored bars in my code here. We have one, the green bar here, where we have our new method, and this blue-white striped short bar and the line where we had our old output, where we have now the call to the method. These are two types of changes that are tracked by Git. The green one means this is newly added. This is added to our file, to our code. This is new stuff. And we can click actually on the bar to see a comparison. On the left, we see the code as it was before. And on the right, we can see this green box showing all the new stuff we've added. We can do the same with the blue-white striped bar in here, which shows us that this was removed and instead this was added. This is a change. So this line existed before, it's just a different content. This was added, and we can also, of course, remove stuff, like let's just remove that line. Now something interesting happens. These all look like green bars. Look at what happened here. It considers now this greet and console read key to be new code. This console write line down here, it considers to be the original, and the console.read key that was below here was removed. So we know what I did. We know I just moved it down and then moved some things up and deleted a line, so this didn't change. This didn't change either. But our Git doesn't know that. It doesn't keep track of how I make my changes. It just compares the files as they were before and after, and it makes assumptions about how those changes happened. And right now it considers this to be the smallest change or the most likely change to reach the new state. Just added these lines on top and deleted this line below. Just two changes that cover everything that happened. Before, it was more of, let's actually look at that. I can, in my case, I'd set it up so I can double click it to open the view. Look at the difference. We have removed this code up here and we added code down here and here. I delete this line, and now it would think that the most likely change is we just added all of this and then removed this down here. It does get the change across. It just isn't representative of what we actually did. It's just the way Git sees the changes happening, which can be relevant. But just so you're aware of it, Git doesn't quite understand how you make the changes, it just knows that you made the changes and tries to figure out what's the most likely set of steps I have to take to make those changes happen. Now, with all the changes that I made, I'm quite happy and I want to secure that. So first, I have to now take these changes, these modified files, and I have to stage them. Right now, we're just in the tab Changes. And we have one change in program.cs. I can see there's a little plus symbol. You can see it here as well if I hover over it, and it's right next to the file. When I click it, it will add all the files that are inside the changes and add them to staged. If I click on here, it will take everything, and if I click anywhere here in this tree, it will only add everything on that level and below it. So if I have several files, I can selectively decide what I want. When I click it, we have now a staged change. Down here we have the changes. Up here we have the staged changes. This is basically our pre-selection. It is our way to tell Git which of our changes do we actually want to carry over. If I click the minus symbol, I'm just unstaging them and putting them back into our general list of this is different now. Also notice this little M here. That stands for modified because this file was modified. It's not a new file, it's not a file we removed. It's just a different file. Well, the content is different. Actually, let's be a bit more selective. Let's go back to the old system here. And let's look at all the changes we have. Now with the newer Visual Studio versions, you can do this in UI. Before that was not possible. I can look at all the changes we made, and I can decide to make only partial staging. You can see it highlighted here. I can go, yep, I want to do this change. I want to keep this method. And now we have program.cs both in the staged changes and in normal changes. And if we compare what we have here, if I open the differential view in the staged changes, it's only highlighting this method. You can see it shows us the old code above. This is what it was before. It is not showing us the greet call because we didn't decide to change to stage it. This is just the changes we made that we decided to stage, which was just the new method. If we look at the changes down here, the method is considered to be part of the system already because this is now a stage change. This list, or this program.cs down here, in changes just shows us all the unstaged changes. Everything that is different from the last, let's call it backup, that hasn't been already staged and selected for we want to save it. So it's basically like the default state. If we haven't marked it for anything, it's just in changes. Once we decide we want this, it is staged. And once something is staged, we can make a commit. Commit is making a backup. We commit to this change. We commit this change to our list of backups. And we can give it some description. The way you write those descriptions can change depending on your company, team rules, whatever. The one I'm familiar with is you write the message as a more or less command. You give it an active tone, present time, like this at read method. The way I think it is, you're writing out the instruction you would give someone to implement this. This is very direct, a bit cold maybe, but present tense. Hey, you add the greet method. And I'm just writing this down, add greet method. And I'm hitting commit staged. Now once I've done this, something you might notice, change, is this little number here. There's a 3, and down here as well. Before I committed, this was just a 2 in both. Also, the stage changes is gone. We only have changes left. which only shows us this greet method instead of the console write line. And in our code, the green bar is also gone, because it only shows active changes. Let's add a second commit. This time I'm not bothering to stage, because I'm just gonna commit all. Add call to... No, actually, let's call it replace output with call to greet. And I'm just hitting commit all. And that's effectively the same as saying stage everything we have, all the changes we have, stage them all, and then make a commit. I can make a shortcut by just saying commit everything we have in changes. Stage everything and commit everything. And now we have a 4 up here and down here. And you might also notice how this number went down from a 1 to a 0 just now. Because this is the amount of changes. If I make anything different, you can see we have one change in here. And I can also undo to return it to the state it was before. So if I go, well, maybe not that, right line. So I make that change and I don't like it. I can just go on this undo button and it will undo the changes to this file, all the changes. So I can go in here and selectively do only individual files. I can also do the undo on the tree. I can't do it on the entire changes list. I do have to do it in the tree, but that way I can undo all the changes and return my code to before. So it's basically just the undo button. Only, I mean, that's why it looks that way, but it is not tied to the active runtime of your Visual Studio instance or the open tab, because it's purely based on everything you've changed that is actually in the files compared to what you last made a backup of. And let's finally look at this number 4. I'm just hitting this view all commits. I could also click down here or go to the menus. There are many ways you can access the view. When I click on it, we see the new view here, which is a list of all the changes we've made to our project or solution or repository actually. You can see these two were added by Visual Studio. When I decided to create a repository, these are the things that Visual Studio did for us. One was adding git attributes and git ignore, the 2 extra files we saw in the file explorer. And add project files. This was Visual Studio just taking everything that was already in our solution and making a backup of that, as it was in that moment. And then you see my 2 changes. Add greet method and replace output with call to greet. We can actually look at the changes that were made. If I double click on this, we get the output on the right. That should be quite familiar to you. Changes. Looks just like in the view down right, on the bottom right here. You can see exactly which files were changed. And I can see the changes that were made with that commit. Can do the same up here. If we go down here, we see actually a couple more changes, because this is where we added all the old files. And here you can also see an A instead of an M, because this was an added file. It wasn't modified, it was added, because before this, the file was not stored in Git. So as far as Git is concerned, this is a new file, it was added. Up here, program.cs already existed, we just modified it. You can also go down here and see git attributes and git ignore. Now git attributes, I'm not gonna get into it. Git has different properties you can change, different settings you can make to it. And git attributes is one of the ways you can interact with it and make changes to it. Git ignore is a bit more interesting. You might want to interact with it. But for the basics, there are UI tools in Visual Studio as well. Now let's focus on this view specifically. Besides the message, you can also see an author. Now I've set it up to use my current stream setup. Usually I would have my private actual contact info in here. This is part of the meta information that is stored with Git. And you can decide what you want to use for Git to input in here. If I go to the options once more, let's make just a screenshot here. In the global Git settings, you can see I set up a name and an email. These are used by default, but you can also change these per repository. So these are just the default values Visual Studio will use when I create a new repository. But I can also make changes for a specific repository. So I can override things if I want to. And that's what you see in these meta informations, this metadata. No, that's not what I wanted. What? Okay, yes. Anyway, this is important for, well, actually teamwork. You want to know who made those changes, who uploaded those changes. And the email is just a very convenient way to have contact details, so you can contact them. And also a way to somewhat ensure a unique name, since a email address is unique. It's tied to the URL of the email server, which has to be unique. You also have the date, and if you look at the commit, we have this weird string of numbers and characters. It's a hexadecimal string, and it's a commit hash. Every commit makes a hash of all its changes. And it is like a unique identifier for that one specific commit. When you want to work with Git command line, there will be times when you need to refer to a specific commit. And the easiest, most direct way is to use its ID, which is the commit hash. So those numbers can actually be quite important. Here's a shortened ID. Can you... wait, you can't. I just noticed you can't see the tooltip. I'm sorry. Let's make a screenshot. Here it is. So the author and committer, both the same name in this case, the date when it happened, and up here is the commit hash, the full one. Down here you just see the short version. I think Git uses SHA-1, SHA1. It's not supposed to be a secure hash. It's just supposed to give a unique hash. So don't worry about the SHA1. Or was it SHA2 actually? Wait, I might have gotten that wrong. I know it's one of the older ones, because it works quite well and it doesn't need to be cryptographically secure in any way. But anyway, that's the idea. That's quite useful. You can also, in this menu, if you're lazy, pick commit ID or copy commit ID, and you can use that in the command line if you need to. Now, looking on the left, we can see the graph. Now, Visual Studio's graph view isn't great, but it's functional for the most part. There are other tools that show you a better graph, more useful one. Once your project gets larger and things happen, some of which you're gonna see in a while, this graph becomes kind of useless. But it's there, and for a simple project, it's good enough. Now on the left side, we have an interesting view with branches and tags. What is that all about? Now let's first get back to our program here. Actually, let's see if I can get this to work. No, it's not showing right now. What did I miss? What did I miss? Do I have to restart to do that? I'm not sure if I have to restart to get that to work. So maybe that comes with the remote? I'm not sure what triggers it. You can see I have these little annotations above my different methods and the class. Reference is just talking about, hey, it's referenced one time in my code up here. But what I'm used to is it also shows other highlights like when was this method last changed and by whom. And I have direct access in the source code to show me, hey, this happened then and then by this person. The more classic way to do it would be through a command, git blame. If I do that, I get this view on the left. And it basically shows me the last changes made to your source code based on which commit this change is coming from. So if we look at the dates, that's not going to help you much because it's all the same day. I made the repository a couple of minutes ago. But if you look at the IDs, things get a bit clearer. We have the 413 up here and here and here. This is basically the first commit that added this program.cs. We click on it, we can see the changes here. That's from our commit where we added the project files. And then we have two other commits in here that made changes in between. One is the 731 we've looked at, where we added the greet method, and 3db9 is where we added the call to the greet method. So with git blame, you can look at every single line of your code and tell exactly from which commit is this change coming from. And associated with that, you also know who made that change, which I guess is why it's called git blame. Blame it on this person, though it's probably more like blame it on this commit. This code is here because of that commit. And it's a very useful tool. Now let's say I want to make a change to my current code, but I'm not sure about that change. I just want to experiment with it a bit first. I don't want to use it for the actual project. So I might have to go back to the current state, which sure I can do. But I might want to work on this on the side while I'm working on the current code as it is. I want to test two different ways to handle my change, maybe. Or maybe I just have a team with a couple of different people and we all want to make changes at the same time. That's difficult. So for most source controls, including Git, we have this concept of branches. I can decide instead of master. By the way, master is also called main quite often. It's just a name, it doesn't have a specific meaning, it can be called anything. We can go and decide to make a new branch. So this is what I get when I click the drop-down. This view opens and I can create a new branch. And I'm gonna give it a name first. Let's just call it test branch. This is the window that pops up. So this is the name I chose, test branch. And based on means, yeah, just base this branch on the last backup from this branch. And master is the branch we're on right now. You can see it on the right on my screen. And at the bottom of my screen, you can see it as well. And there's a little checkbox, check out branch, that I've selected. If I click create now, pay attention to the bottom of my screen or this drop down on the right. Go to create. and I'm now in test branch. I can click on here or up there to see the other branches. Let's open the view here again. You can see it appearing here as well. And you also notice that this is written down in bold, while master is in normal font. If I double click on here or use one of these menus to select the master branch, I can click on there and now master is highlighted, and we see master down here and on the right. And I can go back. And go back, back. I can switch branches as much as I like. This process is called checkout. What a checkout does exactly, we can have a look at when we make a change in here. Let's say I want to have a greet method, greet name. Hello, name. Like that. And then maybe do it like this. Let's just test our code correctly. That worked. Switch to, just for safety. Yep, that worked. Our code change seems to work, so this might be worthwhile to explore a bit more. You can see it's a change, of course. And then add parameter to greet method. And we commit all, just for speed. We can see we have now 5 commits. We view them. You can see parameter to greet method, add parameter to greet method is in here. That's our last backup. If I now check out master, it's gone. If we look at my code, it's just the old code. Let's check out test branch again. And it's back. It's here again. Including my code. Checkout means load the newest backup of that specific branch. Checkout is really take all the files that are supposed to be here from the branch we check out, put them on our system. It's not necessarily deleting the files that exist but are not needed. So that can get a bit confusing if you have, for example, an additional project in test branch or additional files that don't exist in master. It will probably not delete them unless you have specific settings to do that. I don't, so usually I have some superfluous files always in my branches from some test branches, but as long as they don't interfere with the main system, it doesn't hurt anyone. But this is now a different branch. I can also check out master and make now a change in here. Maybe I decide, no, this is kind of stupid. This is just... Why did I bother with it? Let's just go back to write directly. And we do it like that. And now let me remove greet method. Let's make a change happen again. And now we have remove greet method in here. After replace output with call to greet. But in test branch, you can check it out. My code is still here. And here we have add parameter to greet method after replace output. I can also use this view to just have a look at it. If I just click on it without checking out, I just clicked on it once, we can see the commits in that branch. You can see master is in here, test branch is here, and I can have them both in the same view. You can see on the left master and test branch. Test branch is the one we're in right now. And now you can see the graph actually doing something. Instead of a linear line with individual dots in between, we now branch off in here. So this is the last time both branches had the same code. And then both branches made a change, different changes. If we go to master, and then have a look at both, same view, we have master and we have test branch, two different changes. Now let's say I want to actually add my development. Maybe test branch is successful, I like my changes, I want to use that officially now. I want to put that in my program for real. Well, we can do what's called a merge. And there are ways to do that. The simplest one is I'm just right-clicking on test branch. And what I can do now is merge test branch into master. So notice master is the one I'm in right now. Master is my active branch that I'm in. And I right-click on this other branch, test branch, and use merge test branch into master. Now this little window pops up about my merge to confirm it. I can select again the branch I want to merge, and we see something interesting here. One file with potential conflicts. What's that about? Well, we can open the view, which is showing program, of course. That's the only file that we changed. And that's because we made changes in program.cs in both branches. If we made changes in separate files, there wouldn't be really an issue. We might have made changes in master in one file and changes in test branch in another. You know what? I'm going to show you that right after this is done. But in this case, we made changes in the same file in two different branches. And now we have to merge this, because Git cannot figure out how to bring these changes into one file again, how to combine those changes. So we have to do that manually. You can see on the right, I have now unmerged changes. You see both modified. And you have a C now because this file is having a conflict. If I look at the diff view, this is a bit different now. This is the merge view actually. We have the diff between the two branches kind of. On the left, we see the changes in test branch that are conflicting with the changes in master. If you look at the top, you can see the incoming. That's the branch we're trying to merge in our active master branch. And our current is the master. And now we have all these changes in here that we want to combine. And at the bottom here, you see what Git would do to the file based on the current settings. That means if I make a checkbox here on the left, for example, this is the change it will use. The incoming test branch decided this line is going to be changed from just greet, as it was before, to greet Twitch. And so it's using that change. If we decide to use the right side, it's going to change that line to console write line hello Twitch. So we made a change in both branches on the same line, and we're deciding which change to keep. We can do both as well, if we wanted. Can also change the order. If I click this first and then this, it will do it in the other way. So I can decide now how I want to merge things, and I'm just going to decide to keep the left one. I like the test branch more. Of course, if I use the greet method, I need to add that as well. So I should select this one too. And I could select this, but it doesn't really give us anything because I have a greet method. I need to use some code with a greet method in there. Gonna use the code on the left again. And I could also make a shortcut by just saying, ignore my changes in master, just take everything that's in the incoming, at least for this file. At the top, you see some helpful little tools. The most important, we have two conflicts. 0 remaining because we solved all of them. Let's just close the view, don't save. I discarded my changes. Let's open the view again. 2 conflicts, 2 remaining. Selecting the first one, 2 conflicts, 1 remaining. And I can use these little arrow keys here to jump between the different conflict areas. Second one selected, conflict 0 remaining. Once I'm at 0 remaining, no more conflicts in this file, I can accept the merge. And my changes are now saved. This is basically a change I make in this one commit. This is the merge commit I'm going to make. And I'm gonna give it name merge, test branch, and master. Good staged. If you look at the graph now, we have this line that's coming back to the master branch. So we have a little branch going out to test branch. Oh wait, wrong way around, actually. Yeah, this is what I mean with confusing. Or with the Visual Studio graph isn't so great. This is actually the wrong way around. So test branch has this change in here, it's the top. This is from the master branch going to the side where we removed the greet method. And then we merged both together into the master branch again. And yeah, so this line is basically both the master and the test branch up to here. Then we split off to the master to the right and test branch on the left, or on the same position, or the same X position. And then it's master branch again, so yeah. Confusing. Let's go to test branch. We check out. The original code from test branch is here. Test branch original. Looking at master branch, this view again. Let's go to master once more. And now we can also delete our test branch. I just used right click and then delete. My settings are made in the way that if I delete a branch that hasn't been merged anywhere yet, Git will warn me. Right now my master branch has the changes from the test branch. You can't see test branch anymore, but the change is still here. And because that's the only change that was made in my test branch, I was able to just delete it. That commit is still here. I can go back to that if you want to. Those changes are secured. Same with that remove greet method. I completely overwrote that change. I made that in the master branch and then overwrote that again with the changes from test branch, but it's still here. I can still restore that data if I want to. And actually, let's say I want to do that. Let's say I want to forget everything that happened here and go back to this state. There are a couple of ways to do that. One interesting method is called cherry pick. If I right click on the commit, you can see we have this option cherry pick here. I don't use it often, but it comes into play sometimes. So if I use cherry pick, it's a bit similar to a merge, because I'm actually taking this commit and merge it into my current branch. It's like taking a separate branch that only has this as a change and then merging it into my main program. So I do have conflicts in here that I have to solve. And I could select my current target, or I can take my source, which would be the commit I cherry picked. Well, let's do that. I pick the source, the incoming, which is the cherry pick commit that deleted the greet method and just use console write line again. Accept the merge. And let's call it cherry pick. I'm just not gonna call the commit continue. Actually, right, I don't need to give a commit message, sorry. Because I have that already. I cherry picked this commit and we're just gonna use the same name again for this commit up here. So it's basically duplicate commit. And I can do that not only from within the same branch, where it doesn't make too much sense, I can use it from other branches. So I can create a completely separate branch, make changes in there and decide, of all the changes I made in this maybe test branch I had, this prototyping branch, I want to have this one specific commit in my main program. Everything else, not useful, don't care about that. You just right click it, select cherry pick, take care of potential merge conflicts, and you're done. The other way we might get back down here is with a reset. So right now, I cherry picked this remove method, but actually that was a mistake. I don't want to have it directly. I want to keep the greet method. So I can go to the state I want to go back to, like right to where I merged the test branch in, and I right click again. And in there, I have the option to reset. And reset comes in two flavors: keep changes and delete changes. Mixed or hard. When you're not sure what to do, select the keep changes. When in doubt, keep changes. Delete changes, sometimes if you know exactly what you're doing, then just go for it. I'm gonna select keep changes because I am not too sure this is a good choice, so I'm doing that. You can see the commit is gone. I'm back to merge test branch, but because I decided to keep the changes, everything that I've lost, so to speak, the commit I've deleted, is now in here, in my active changes, as if I have just written them. If I had selected delete changes, it would be the same as saying here, undo changes, completely gone. So that's why if you're unsure, keep the changes, you can simply undo and delete them that way. That way is a bit safer. If you didn't intend to reset or reset to the wrong branch, you can still kind of save everything by simply committing all your active changes again, and that way you still have them, though your commit history is a bit gone. Now let's make a little change here. Let's make a new class, just to have comparison. Actually, no. Let's make a new branch here, new test branch. I'm gonna call this develop. Develop and master are currently right on merge test branch and master, same state. And now I'm in develop and I'm gonna add new class greeter. I'm gonna take this method, the greet method. I'm gonna put that in here. Let's call it public. Yeah, that works. And then in here we have to make that greeter.greet. Of course. I have all the changes in here, and then move greet method to... Wait, was that how I saw? Separate? Separate? Ah, who cares? Commit all. Looking at our code. We are still branching off. We can just not see it because master is on the same line still. But if we go to master and make another change, we would have a separate branch coming off again. But let's just keep it at that. Actually, let's merge develop in for now. Merge develop in master. This time things are a bit simpler. It will change 2 files, but there are no conflicts because we haven't made any changes in master, so there are no conflicting changes that we have to decide on. Merge in master staged. And now we have master with the develop merge and develop itself. And now let's make a change in master to program.cs. And now let's do it down here and make that let's add an output in here and sort of that. And then let's switch to develop and make a change to greeter. And make a change on there. Maybe make those as well. And that's additional outputs to greeter, commit all. All right. So we have once more 2 branches with 2 different changes. See, they're split off down here, and we have 2 different things in here. On the right side, we see the master branch. There's the merge that happened last time. This is still the develop branch. It doesn't know about the merge because it doesn't need to. It only has the next change up here, additional output. Now let's go back to master and merge develop back into it. And even though both branches have changes, there is no conflict because the changes happened in 2 different files. So again, there are no conflicting changes. So merge conflicts is what we'll call that, only happen when the changes affect the same parts in the same files. If you change different parts of your file or just entirely different files, then Git has no problem figuring out what to change and what to keep. Only when you make the same, or only when you change the same positions in your file in 2 different branches is when Git doesn't know how to proceed, because it cannot make that change. That is entirely then up to you how you want to handle the change. So we just merge, everything is fine, no conflicts to solve, and we're just gonna make merge develop in. Actually no, this time I'm gonna make a different view. I'm not gonna commit the merge, I'm gonna abort. I'm getting questions about confirming that. I just selected yes, and I aborted the merge. So we're back at the old state. 2 different branches. I'm gonna right click on develop and delete it. And because this time develop has a change that's not in master, I'm getting this warning message. So I'm gonna hit cancel and I'm doing the merge once more. Merge develop and master. Merge develop and master. Staged. And now I can just delete develop and no boring messages because the commits that were in develop but not master are as well in master now. So they're still here, I can still use them, they're secure. Those are the basics for how you can use your Git if you're working by yourself on your PC. But usually you would include other people in your work. And even if you don't include other people, you probably have some kind of secure backup of your entire Git on a different machine. This different machine could actually be the same machine, now that I'm thinking about it. Point is, you don't want to have your Git repository just in your solution. You want to have a complete copy of your Git repository in some other location, just for the safety. Because that is your source code. If you're a programmer, that's your lifeblood. If you lose your source code, you're done. Your source code is your most valuable asset. If you worked on a large project, the countless hours you sunk into that before you can ship it out, you can't afford to lose all of that. So you make a backups. At the very least, you have a separate copy on it on your machine. Ideally, though, you would put it on a different machine. Maybe even that different machine could be in your local network. Or it could be on a USB stick, for all I care. The thing is, you do have some remote location, at least one, that has full copy of a repository. And one of the more popular options is to have a special server that's optimized for Git. Though you can have a remote copy that is literally just a different folder, which is what I'm going to do now. I'm going to set up a new repository. Let's see. Did I get this wrong? Git. Okay, I don't... Is my Git not working? Ah, okay, now it worked. And I made a mistake. Oops. That's what's the wrong directory. I'm sorry, I'm sorry. That goes away, that goes away. Let's just delete all of this. Let's make a new folder. Secure storage. Okay, that's yeah, okay, that's fine. Then let's make a new one here. For introduction to programming, and I'm gonna open the PowerShell here. Does it still work? No. No, not slash. No, not dash. Minute. Okay, that worked. So what I've done is set up a repository, a bare repository, and completely empty Git repository, just purely the fundamental infrastructure for a Git repository, inside a different folder on my machine. This can be a folder on USB stick, on external hard drive. It could be a network folder inside your intranet, maybe on a different machine or a NAS or whatever. It could be on some FTP server, whatever you have lying somewhere on the other end of the world that you reach through FTP connections, or maybe a tunnel. Or maybe it's actual server software that connects with your Git repository. But in the simplest case, you just have a file folder somewhere set up. And if you look on the right, on the left here, my branches currently contain only my master. I'm going to make some changes. I'm hitting the options for my remotes. These are the options for my specific Git repository right now. Recognizes we have the global settings in here, the standard values, and then the settings for my currently active open repository. And there's remotes. And this is where I'm going to add a remote. And this is just doing the classic copy as path. Like that. Let's make a screenshot of that quickly. Now, a remote. The classic name for a remote would be origin, but it can be named whatever you want. And right now, because that's possible, I simply use the path directly to that special folder that I've pre-configured for Git. And since the checkbox down here is selected, it will just copy that into push. For the most part, you will always have a system where fetch and push are equal. But there can be special circumstances for one or the other. I've never had those happen to me, so I always use the same for fetch and push. I'm gonna save that. It's now in here. Origin is now defined as a remote. And now at the top you see another line. Actually 2 lines. And you can see all these arrows appearing here. That is because these are all commits I have on my local machine right now, in my repository, that don't exist on that remote. That's why I have my local history 12 outgoing, in the sense that I have 12 changes that should be going out. And to move them out, what I do is called push. And there are a couple of different ways. Again, you can access push. I can click here on push. I can click on the arrow up here. I can right click on things and go to the Git menu. And there are a lot of, again, in the Visual Studio UI, there are a lot of ways to access the same features from different parts. I'm just going to click on push up here. And it moved the files over, or is trying to. Let's look at the source control Git. There we are. This is now remote's origin. We have our local repository. We have our master branch in here, the one we're used to. And then we have the subfolder remotes, and specifically remote origin. You can have several remotes. You can have several different locations where you want to make backups in. And you can see in remote's origin, we have also one branch called master, which is right now an exact copy of our one. Specifically, we've linked our master to this remote master. If you look in this line down here, branch master set up to track origin master. You see the name of the remote / name of branch. Those branch names don't need to be the same, but they usually are, and that just means these two are linked. When I make a change in our current code, let's say to exit, at verification to message, commit all. I now have an additional commit in my local branch that doesn't exist in the remote branch. It's like a different branch, but they're both supposed to be the same. So I'm pushing once more, pushing on the remote branch, and now it has the copy of our current repository as it is right now. So when you're working with Git, you probably want this line down here to be 0 at all times, or 0, 0. You want to make sure that your changes are always backed up somewhere else. let's try something. I'm gonna make a reset here. I'm gonna delete the changes. So right now, my current local branch is actually behind the master branch on here in remote. We have this additional commit in our remote branch, but our local one doesn't have it. So it's listed in incoming. In this case, we don't want to push, we want to pull. Pull means copy all the changes from the remote branch that we are lacking into our current one. And by the way, let's reset again. Yes. So right now we have an incoming. Let's say press any key to exit. Let's make like that. We make a different change in here. At output change something. Now we have an interesting situation where we have both an incoming and an outgoing commit. This is again a case of we have two different branches and we need to merge them. We have the master branch locally with this change, and we have the master branch in the remote with that change. If I just try to push, I get this little message. It tells me we have different states. We have a conflict. We can't just directly push because there's a change in the remote that we don't have yet. So then we can decide to hope for the best and just go for pull then push. What I'm going to do is I'm just going to go for the pull and then deal with the conflicts. Or you can turn down the brightness of your monitor, I guess. I like light mode. It's easier on my eyes. Prefer it usually. Though I don't have perfect eyes, so I've heard that is one of the reasons why some people might prefer light mode. I do wear glasses. So yeah, we have basically just another merge now happening between the remote and our local master branch. And I'm gonna decide to take the remote version and accept the merge. Alright, merge in master in master. So we have merged the two. And now that we have made the merge, I can successfully push because the conflicts are solved and we're again same state in both branches. And the best part about this is this remote server or remote location that might be in a network somewhere can be accessed by other people as well, like your teammates. So you can all work on again, off again on a project and just upload your changes to this remote server when you're finished. And then when you start working on it again, you can first go to your local branch and pull to get all the changes everyone else made since the last time you pulled. So the remotes are not only a way for you to make a backup of your repository, of your entire source code, they're also a way for you to easily share your changes and your entire code projects with other people. That's why things like, of course, GitHub are quite popular websites for developers, since they are literally servers that are reachable through the internet that you can host your repositories in. So this remote origin could be on GitHub, for example. There are other ways to store that, by the way. You can also set up your own private servers, even on the internet, or you can set up servers on the intranet for only your company or your team internally. You could also just connect to your colleague's machine and directly interact with their local system. You just have to set up your firewalls to make that connection happen, but it's possible. So Git is rather flexible in that way. And of course, let's assume you have a situation where this remote is just the USB stick I've mentioned twice now. You could just give them the USB stick and they pull the files from there. So you don't even need a network connection to share your code with other people. You can still have this one USB stick as a common ground to easily share changes without directly conflicting with your things, because whenever you pull stuff from there, you can review the changes first and merge it with your own changes. So again, Git, very useful tool for teamwork, not just a way for you to make backups of your code. Right, I wanted to explain the tags as well. Tags are essentially a way to give a unique special name to a specific commit. In my company, we use them usually for software releases. Whenever we make a release of our software, we just mark the commit that was released, and the tag will have the name of that version. So let's say this commit marks the release of our software. I'm gonna just right click on it and use new tag, and with that create a new tag. I'm getting this little window that I can fill out. Tag name 1.0.0 release state for version 1.0.0. And now I have this little tag symbol in here. And on the left, we can see actually a drop-down specifically for tags. So we can see master is currently this branch, and it is all of these extra commits on top of the last release of version 1.0.0. If I want to go to that version specifically, I can click on here and see what's going on. Can also check out that specific commit, interact with it somewhat like a branch. I think a different way to look at it would be tags are a way for you to interact with a branch frozen in time. Like you can always go back to that specific state of your software as it was back then. No, that doesn't quite fit. A tag is just a name for a specific commit. Let's keep it at that. By the way, if you want to successfully share this, at least in Visual Studio, you unfortunately have to go through additional steps. On the 3 dots menu on the right here, there's an option for push all tags. Unfortunately, that's something I have to select to push my tags, the tag I just made, this 1.0.0, to remote origin. Otherwise, this tag only exists on my local machine. Even if I push any changes, this tag will stay with me. I have to specifically push this tag to remote to actually have that stored on remote for someone else to get the tag as well. Not sure what that's about, why that's not an option to include that by default, but there are probably reasons for that. Alright, I should probably share the command I used. So I just created a folder, an empty folder, in the path I set up as a remote. So I just created that folder. And what I did in there is use a git command. It's this git --bear init. Git init is the command just to set up the basic Git repository, and the bear is just a hint of please don't fill any data in there. It's just the pure infrastructure to be filled by us with our first push. So if you create a folder anywhere on any file system, then use this git command in there. It will create the basic repository infrastructure, and then can you set this or some network path to it as the remote and interact with it like a normal remote in Git. Can be a normal folder in your file system. Unless, of course, you already have some Git server set up. Maybe one of the popular hosted ones like GitHub, in which case you can, of course, just connect to the address they provide you. And I think that's it already. That's the basics for Git and Visual Studio. Very useful tool. There are many cool things you can do with Git that I didn't talk about, that are very specific sometimes, and some are just depend on your team and how you set up your structure and how to interact with other people. Something you should probably look up is a thing called pull request. So far I just pushed directly with the command push, this thing here, to just push things to the remote server. But maybe in your company that's not a good idea. You don't want people to just upload code directly. You want someone else to check that code beforehand. So not necessarily to prevent someone from adding malicious code, but more as a have someone else check for some basic errors. That's not a default system in Git. It's a pretty popular system though, that many Git servers or Git hosting solutions add or offer as an additional service. So you should, if you use one of the popular hosters for Git repositories, you should look up if they have pull requests, if they support that, and if so, how to implement them, how to properly use them. Because again, they're not directly Git, but they're very useful for Git. But that's it for RIA. Right? And not only are we done with this episode, with source control covered as well, that's the end for Introduction to Programming. We're at the end of the series. Everything else that we could talk about is no longer an introduction, because the introduction is long gone. We're getting way too complicated now. I'm not gonna stop streaming, but the series itself is ending. Future streams will probably focus on just programming exercises and little tidbits, good to knows. And I'm gonna embarrass myself with live coding, just so you can get some confidence in. Even people with decades of experience are bloody idiots and noobs. And people laugh at them on the internet all the time. So, until then, have a lovely Sunday. Bye bye.